I'd like to explain how exactly this machine works, right? What this machine does is it carries out the 4 stages of gasification. In gasification, you want to take this material, you want to take the biomass and you want to convert it into a clean burning gas. Now, the problem with most biomass, such as wood chips or nutshells, is that there's fixed carbon and there's volatile carbon. And the volatile carbon tends to form a sticky substance called tar. The tar is very flammable. However, if you feed that into an engine, it will gum up the valves of the engine, right? So what this thing does is we're basically converting all of that into hydrogen and carbon monoxide. The way that works is the feedstock starts in the hopper and it descends into this vessel over here. This vessel is a double-walled vessel known as the drying bucket. The drying bucket reclaims waste heat to dry the material so that we can actually carry out the chemical reactions. An auger inside this drying bucket, the auger motor can be seen on that side. An auger inside this drying bucket pushes the mass, the dry biomass into this reactor here. Now, inside this reactor, pyrolysis occurs. Pyrolysis is the process of making charcoal. So what happens is the engine's exhaust is still extremely hot. All of that energy would normally be wasted, but what we do is we reclaim that energy to convert the biomass into charcoal. And all of the smoke that comes off in the process of making charcoal, that's the tar gas. In order to keep this process going, we burn that tar gas. So when we burn the tar gas, it produces carbon dioxide and water vapor. Now, carbon dioxide and water vapor are waste products and can't really be used by themselves. However, the charcoal by this point is red hot. And red hot charcoal has an interesting chemical property. Really hot charcoal has a very high oxygen affinity. What it will do is it will take the oxygen right off of water vapor and it'll produce hydrogen gas. And in the process of doing that, that oxygen combines with one of the carbons and produces carbon monoxide. Also, when carbon dioxide percolates through the red hot charcoal, the same thing occurs. The charcoal will remove one of the oxygens from carbon dioxide and it will form 2 carbon monoxides. Now, carbon monoxide and hydrogen are both extremely flammable and they burn clean. And that's actually what we feed into the engine. So upon reacting, the charcoal descends here, and actually the reaction is occurring down here. In here there's a basket which holds all of this charcoal. And as the gases percolate through the charcoal sublimates away and forms this carbon monoxide and hydrogen. And those hot gases ascend in this gas cowling across a heat exchange system that recovers most of its usable heat. And that preheats the air and maintains the high temperature of the reaction needed to produce very clean gas. After ascending the heat exchange mechanism, the gas comes into this cyclone where it spins around, almost like a vacuum cleaner cyclone. In that spinning process, all the dust and all the charcoal bits that remain suspended in the gas separate out and fall into the can below. Right? There's a cone-shaped tube inside this cyclone. So after descending the cyclone, the gas is now cleaned of particles, and it's still very hot. And so what happens is that gas ascends this tube, goes all the way down and back into this vessel. So this drying bucket is a double-walled vessel. The gas does not actually mix with the biomass. It simply exchanges heat across the heat surface. Right? After giving up its heat, what happens is that gas descends this tube down here. Right? And when it descends here, it enters the bottom of this filter. Now, when you're starting the gasifier before the temperature is up to proper temperature, also during the grate shaking, occasionally some of the tar will escape the cracking process. One of the things that our reactor optimizes for is tar cracking. It's very difficult to burn all the tars, and so when we carry out these reactions at very high temperatures, the remaining tars that don't get combusted thermally break apart into hydrogen and carbon monoxide. However, once in a while, when that process is not optimized, a little bit of residual tar escapes, and this filter will capture those gases. Now, this filter is actually filled with more biomass. Normally, we would fill this with either wood chips or perhaps even sifted nutshells. And the tar gases that condense on this biomass can actually be reused when you change the filter. You would actually take the biomass in here, dry it out, and actually mix it with your fresh feedstock and reclaim the energy that's in the tar content. So after filtration, the gas should be clean enough to use in an engine. The gas then comes through this pipe here, right? And this is the air intake. Air gets drawn in here and gets mixed with the gas. And then it gets fed into the engine where it gets consumed, right? So if you'll take a look over here, this vessel here is the condensate vessel, and the condensate vessel actually captures all of the condensation that comes out of the liquid after it mixes with air. And this also has a larger capacity from the prior version and should be able to handle 24 hours of operation. And that concludes our walk around the power pallet. If you have any questions, please feel free to visit our YouTube channel and or to email one of our sales associates.